This is for Algebra 2, problem A-34. This is very much like the problem that we did in class with the bouncing balls. And the first part of this is to come up with the rebound ratio. And recall that the rebound ratio was the slope of our best fit line in our classroom exploration. Well, the slope is just the change in the y over the change in the x. So what I'm going to do, instead of making a best fit line, I'm going to look at this data and I'm just going to take two of these data points and I'm going to subtract the y's to get my change in my y and subtract their x's, and I'm going to come up with a rebound ratio. So for the first two data points, I have that y, this one here that says 59 centimeters, and I'm going to subtract the 124. That would be my y, and for my x, it would be 70 minus 150. I put that in the calculator, and I get the decimal answer of that, 0.8125. Now that would equate to 81%, but we need to keep this in the decimal for this rebound ratio. And I'm going to do that with the next two set of data points, and again find the decimal for that, and another pair and find the decimal, and another pair and find the decimal, and yet another pair and find the decimal. You need to do this with a lot of them, and because what we need to do is average all of these together. And that's why the answer that was posted said answers could vary but should be close to 0.83. Well, my answer actually was 0.84. So my answer is not exactly the same as it was in the book, but it said answers could vary but be close to 0.83. So this is the number I'm going to use. I'm going to use this number to calculate, which means my answers will be slightly different than the answers posted, as yours might be. If you ended up using different data point groups here, and then you averaged it out, you might have gotten 0.82, or you might have gotten 0.83, maybe 0.85. That's a little bit high, but it's possible. So I'm going to use that rebound ratio now to do my predictions. You're going to have the drop height times the rebound ratio, and that will give you the rebound height. So in the next problem it says drop it from 275 centimeters. So I multiply it by the rebound ratio, and the answer there would be my rebound height would be approximately 232 centimeters. Different than the answer posted because, again, my rebound ratio was slightly different than theirs. I did notice that those answers, which are from the textbook, they changed it all of a sudden, some of their answers from centimeters to meters, but didn't do that properly. So mine are all in centimeters. All the units are in centimeters. The next problem was what would be the drop height if it rebounded 70. So I'm putting that in the equation here. I'm putting the 70 for the rebound height. I still have the same ratio that I'm going to use, and now I need to figure that out. So I divide both sides by that rebound ratio and calculate that on the, use a calculator, and I get approximately 83 centimeters. And so that would be the answer to that problem. The next one was start dropping it at 200 centimeters. Actually, it's 200 feet, I guess. Oh, I think I have to hold on just a minute. I had to change my units because this one was, you dropped it from, I believe it said 200 feet, or I can't remember what the units were. Just whatever the units for this 200 was, that will be the same as my units here. So I'm going to take this amount, this height, this drop height, multiply it by my rebound ratio, and I get 168 units. Now, it's going to bounce again. But now it's dropping from that rebound height of 168. So I multiply it by the 0.84 again, and I get a height of 141. Once again, it bounces, and so I'm basically starting. My drop height is that rebound of 141 times the rebound ratio, and I have 118. And I went all the way to 4 bounces. 4 bounces, and so the final one would be 99. So that is how we do this problem.